Hi everyone, in this video I'm going to go through question number 1 from the 2012 AP exam. So like a lot of the questions we've looked at in this practice set, we start off with a table of values here for the temperature of water in a tub. And they give us some information about this function W. We know it's a strictly increasing twice differentiable function. We know the initial temperature of the water is 55 degrees. And they're giving us data for the first 20 minutes of time. So our first question says to use the data in the table to estimate W prime of 12. And we've done this in quite a few problems. So to estimate that derivative, we're just going to use the average rate of change. So I'm going to take the points like the interval right around 12. So we are going to calculate the average rate of change. So W15 minus W of 9 over 15 minus 9, and then take data from the table. So 67.9 minus 61.8 over 6, which gives us, let's see, what is that value? I think it's 6.1 over 6, and I'm going to go 1.017. AP conventions usually say to round to the third place. And then my units would be degrees Fahrenheit per minute. So that was the first part, just estimating it. Then it tells me to interpret the meaning of the answer in the context of the problem. So since we were estimating a derivative, we know what we're calculating there is the instantaneous rate of change. So we're calculating how that temperature was changing at time t equals 12. Well, since our derivative is positive, we know it's increasing, and it's increasing at the rate we just found. So I would say something like this: the temperature of the water. So what's the thing we're talking about is the temperature of the water. It's increasing at a rate of, I'm going to say approximately, because we use the average rate of change to estimate this. So it's increasing at a rate of approximately 1.017 degrees Fahrenheit per minute. And then we have to tell when that's happening. At time t equals 12, and the units on time were minutes. So that would be a complete explanation. Say what you're talking about, what's happening with units, and then give the time that that's occurring. And so as far as points here, it was 1 point for that estimation, and then 1 point for the interpretation. All right, so part B now says use the table or use the data in the table to evaluate this integral, and then again interpret the meaning of that integral in the context of this problem. So if I have this integral, in order to evaluate an integral, I know that I have to take the antiderivative of the function. Well, the antiderivative of w prime of t is just w of t plus c, and we're going to evaluate that from 0 to 20. So I have w of 20 plus c minus w of 0 plus c. My c's are going to cancel. W of 20 gives me 71, and W0 is 55. And if I subtract those, I get 16. Let's see. My units here, well, my units, if I think about this, my units for W prime would have been degrees Fahrenheit per minute. Now, when we do that integral, we're going to multiply our x and our y values. So when we did the integrals, we were really taking degrees Fahrenheit per minute times minutes, making our units here degrees Fahrenheit. So that's our that's how we evaluate the integral. Now we have to interpret that meaning. So what we were doing is taking the integral of the rate here. So we are integrating that change, or the rate at which the temperature was changing. When we integrate that rate, we get a change in the amount, so the actual change in the temperature. So here what it's telling me is that temperature, since my integral, that value was positive, the temperature increased by 16 degrees Fahrenheit over that interval of time. So for this problem, we would say the temperature of the water increased by 16 degrees Fahrenheit over the time interval t equals 0 to t equals 20 minutes. And so what we have for points here was 1 for the evaluating the integral, and then 1 for interpreting it. All right, for the last part here, it's telling us for the interval between 0 and 20 minutes, the average temperature of the water in the tub is given by this expression. So they want us to use a left Riemann sum with the 4 subintervals in the table to approximate this integral. So we'll do that first. So now the left Riemann sum is just going to help us deal with this piece right here. We're not dealing with the 1 over 20 yet. So I'm going to take this and we're going to use our Riemann sum to deal with that. So my intervals are going to be 0 to 4, 4 to 9, what do we have, 9 to 15, and 15 to 20. Sorry for all the scrolling back and forth. So 0, let's see, I've got 55. That was a left Riemann sum, so I've got 55. At 4, it's 57.1. 9 is 61.8. And then at 15, we've got 67.9. So now my data, or my integral is going to be approximately 4 times 55 plus 5 times 57.1 plus 6 times 61.8, and then plus 5 times 67.9. And let me put that in my calculator. And it looks like I get 1,215.8. Now here I have to be careful because I haven't quite yet answered the question. I need to approximate this whole expression here. So that means I have to take 1/20 times what I got, 1,215.8. And that gives me approximately 60.79. And that's the average temperature of the water. And we know the temperature was measured in degrees Fahrenheit. So now we've approximated that expression. We've approximated the average temperature. And now it wants to know, does this approximation over or underestimate that average temperature? So that has to do with our Riemann sum here. So what we need to know is a little bit about our function. And it tells us here that our function is increasing. So I'm going to draw a sketch. I've got an increasing function over some interval, and I'm using a left Riemann sum. So that left endpoint is what determines the height of my rectangle. Then we can see that rectangle lies below the curve, so our answer is going to be an underestimate. So I would say the approximation is an underestimate because, let's see, our function is w is increasing and a left Riemann sum is used. Okay, so then last thing here for points, we got 1 for just coming up with the approximation of the integral, 1 for approximating that average value, and then 1 for the answer here stating that it's an underestimate and then explaining why. All right, thanks for watching.